Hello, and welcome to ideastatica webinar. This webinar is dedicated to engineers who deals with concrete structures, and we are going to present you some hopefully useful tips and tricks for our detail application. I'm Thomas from ideastatica, and here with me is Petra, the concrete expert, who is the main person of this webinar and who will lead you through all of the topics here. Hi Petra, how are you?
Hello, fine, thank you.
But before we start, let me tell you some technical info. You are muted by default, but if you want to ask questions, please use GoToWebinar application. You can find the question part there and write us a question. And during the webinar, we will answer this question, or if there will not be enough time, the question will be answered after the webinar. If you can't see this application, you need to click to the arrow in the grab tab in the top part here. Now let's go through the agenda of this webinar. Petra will start with the general introduction, where she is going to recall what is detail application, what is it for. Then she is going to go through some practical examples where some, as I've said, useful tips and tricks will be shown. And at the end of this webinar, we will go through some new things that are prepared for the next versions. And of course, at the end, we are going to have some time for Q&A. But before we really start, let me ask you one question. It is how familiar you are with ideastatica detail. So I'm launching the pool. And now please answer how familiar you are, if you use it regularly or weekly or very rarely, or if you want to just see what is detail and what is it capable. So we are getting some votes. We have, let's say, 50% of attendees voted. So I'll wait next few seconds, let's say 10 or 15 seconds. So thank you for your votes. And here are the results. So what do you think, Petra? Did you expect it, that kind of result? We have pretty, let's say, some users are using it regularly, very rarely, but we don't have much users who use detail weekly.
Maybe it will change after the webinar. I'm glad that we also have some newcomers that are here by chance, and they hear about the detail for the first time. So I hope it will be a good introduction. Okay, I can probably start. So I will take the presenter. Okay, can you see my screen yet? Okay, thank you. Okay, so I have a just brief introduction. I'm glad that we have some newcomers. So basically, we will focus, or I will focus mainly on ideastatica detail 2D. The application was developed for designing reinforced concrete, and it's powerful tool, especially for discontinuity regions. The regions you can see marked by letter D on the slide, and in general, it's the part of the structure where a sudden change of dimension or where the significant amount of load occur, and where you usually use, for example, Strat-and-tie method or some scientific tool. Ideastatica detail is designing tool, so it provides you also not only ultimate serviceability limit state check, but also serviceability limit state checks, and it provides you to design the structure in almost no time. It's a designing tool, so you don't have to do complicated models, and it's not so time consuming like other more scientifically oriented software. I don't want to go too deep in theory, as this webinar is focused mostly on practical tricks and tips and how to work efficiently with the app, but I would at least clarify the most important parts. This webinar is dedicated detail 2D, where the compatible stress field method is implemented. The method was developed by our company, ideastatica, together with the University in Zurich, ETH. And the most important assumptions are that the tensions in concrete are or is neglected, and it's covered fully by reinforcement. So it follows that the solution is only suitable for the reinforced concrete or reinforced concrete with pre-stressing. Also, this mode is only for in-plane examples, so we have to simplify the examples into the plane and use only in-plane loading. All other assumptions or limitations or material models and information can be found in theoretical background on our webpage. We also have other articles related to the topic about the method and so on. So as Thomas already mentioned, the first part will be a simple example where I will try to show most of the tips and tricks. And then in the second part, I will break it down even more and I will show other examples, but I will not do the modeling from the scratch to the result interpretation. I will do it only with the first example, but the example as it is, it's not so relevant because everything I will mention, you can also apply it for the designing other parts of the structure like walls, frame corners, or something else. It's very general. And since I'm using 2D detail, I simplified my example, this foundation, only to the plane example in the direction where the load is dominant. If I wanted to see the other direction, I would have to solve it separately, and I will focus purely on reinforced concrete design. Okay, so let's start. When you see the application for the first time, you can find the concrete part and open the detail. I already opened it. And then there is a like crossroad if you want to use 2D or 3D beta. Now we will focus on 2D and I will start from the beginning. I want to do something general, so I will not use any template that are already prepared. And important thing, you need to set the design code at the beginning. You are not able to do it later. Everything else, like initial settings for concrete reinforcement, cover, you can change later. So, but this is important to remember. So I will set Eurocode as I'm used to work in Eurocode. Okay. So I have a blank project and I will start with the model entity. This is a first info or tip I would like to give you, because you can use different subregions, or let's say entities like walls, wall, beam, knee joints, and so on. But the important thing to remember is that the model is always the same. The concrete is always represented by 2D elements, and for the beam entity only has some like better options how to input, for example, stirrups or internal forces when you have a part of the structure. But in general, you can create anything anything you wish, and it will always be the same finite element model at the end. The wall entity is the most general, so I will use that one. It's also my favorite because I can use DXF import for the shape. But right now I will try something else. Not everyone is aware that we can also input coordination, so I will start with that. Basically, when I want to use coordinations, for example, from Excel, I need to pick shape by polygon, and then I need to click on edit shape. I already have some coordinations prepared, and easily by Control C and Control V, I can input the numbers. The tricky part is that you need to click to the corner and you don't see that something is selected. And also it's better to have the number of the row in the Excel sheet prepared. Okay, so see, I have the shape I wish. Maybe I will show you what I am trying to model. I'm trying to create such a shape. You have more options. I choose to use coordinations and do input the parts one by one, and the software will automatically connect the parts together, so it will be one structure. You don't have to do anything extra. So I will continue. The second one I will define by rectangular shape, because it's the easy one. Just let me change a few dimensions and move it a little bit. The position can be changed by the points that are related to each other. It's very good thing to learn at the beginning because you will use it later as well. So basically, I want to set which shape is the master one. It's the only one for me that is there, and then I need to pick the master point of the of my part. So I want to set this point as the master one, and then I will move the number one from my new part to the original one, like this. Okay. Then the other part, I will again input my coordinations. And again, you need to click to the corner. It was inputted to the 0, so I need to again move it to the side. And this time I will use as the master part the V2, the small block. But again, it's 2 and 1 that I want to put together like this. Okay, so it's pretty easy to build. And the last one will be again the simple rectangular one, where I only change dimensions and move it also to the middle as the part of the column where I want to then later input the internal forces. So the position again is regarding to part 2, but this time I want to pick as the master point number 4 in this corner. And already I have set number 1 here. So that's it. Now I need to set some thickness. As I said, it's a 2D solution, but you can still display how the structure would look like in 3D. And it's good thing when you want to check if you set the right thickness, for example, because then when you set calculation of self weight, it's regarding the volume. So it's good to know that it's correct. And see, I didn't change it properly, so I can do it now. I can even use multi-select, so I can change more parts at the same time. Like this. Sorry, it was the wrong one. Let me check what's the right thickness. So the last one should be just 0.65 as it's the column, and this is 2 meters for the foundation. So I have the basic shape. Okay, I can check if it's right. And I'm going back to 2D. The next step would be to set the boundary conditions. We have more types of support. We have already streamed a webinar that is focused only on types of the support, and we also have nice article in knowledge base in our support center. So if you want to know more about each support, you can go there and write something like types of the support to the search box, and you will find it. For this example, I will use line support. This is quite special one, as we can also set the stiffness of the spring if we don't want to have normal support, and we can also turn on only compression mode. So it's great tip when you want to use it for example piles or soil substitution. So that's what I will use for my foundation. So when the button is orange, and also when you see these arrows, it means that it's working only in compression. That's what I want for the soil. And I can also set the stiffness that I took from the tables. When you want to use it, for example, for the piles, you need to calculate it. It's usually from the reaction and deformation. I use the soil, something like good soil like gravel. You can find it in the tables, but please just be aware that you're using line support, so you need to recalculate the units. Okay, I will just copy that and use it also on the other edges. You could also use type of input by polyline, and you could even input like different stiffness. And that's it. It's that easy. You don't need to do any other modification like connect the support with the finite element. It will be done automatically by software when the software will create the mesh. If you want to check how it looks in the real view, you can check that it's like everywhere. But then in the model view, you can see how it goes to the calculation. Here you can really see that it's only 2D solution. All right. So we have the support, and now let's go to the probably the most not annoying part, but it usually takes the most of the time, and it's the reinforcement. We have some options how to input the rebars through the software, but there is also a special feature, and it's the X-import that you can use. I already prepared the XF file before the webinar, and now I can use it that I have something already prepared in advance, and I don't have to do it again, especially for the reinforcement that is like, I don't know, in the corner or inclined. It can be easier to just put this import. So I will try to import this, and the rest I will model in the software. What's a good trick to know? In general, you need to have a polyline in DXF to be able to import the reinforcement. But if you set some thickness for the polyline, and you will distinguish the polylines according to layers, and you will have a different thickness, it will be also import with different thickness, and you don't have to set from the beginning, or you don't have to set again the diameter of the reinforcement. It will be take from the original file according to the thickness of the polyline. Okay, so I choose which reinforcement I want to import. I click on the selected, and I can confirm and go back. See, and now you can see that I have even different diameters because it was already defined in the other file. Okay, so it's quite easy, but I still missing some reinforcement, and I decided that the rest I want to define in the software because I would like to have them in one group, because then I can modify it at the same time. So I will use a group of bars. I will change some parameters and like anchorage type and diameters. And what's most important, I need to define the position. For this, I will use the definition by 2 points. When I will use again the master points as I did at the beginning with the structure. But first, I will also change the number of the bars in one layer and also the number of the layers, because I don't want to do it. I just want to modify the whole group at the same time. So again, I will pick like the master or point 1, this point number 1 from the first part of the structure, and I will like to move it a little bit in the Z direction. Then I will do the same for the end, but this time I need to pick this point, and again I want to move it up and do it like this. Good. Okay, now let's see quickly at the rest. It will be in the similar way. I need to also define the reinforcement for the column, and for that I will use the edge. So I want to use the edge of the column. It's another option how to do it. So it's up to you, but you find like the more efficient solution. And I want the reinforcement continue all the way, and I will use cover from the setting, and just I need to change the anchorage type because my reinforcement continue through the column up like this. Okay, I will just copy that and use the different edge and switch the anchorage type so it's the same. Now let's do the middle one, and again I can use the copy. I don't need to start from the scratch, and I will define it by 2 points like the previous one. once you are familiar with that, it gets pretty easy. And now I need to define the reinforcement according to points on the middle part and on the column. So just let me change the cover and the position, and before and again. And okay, that's it. You can see that I have again wrong anchorage type, so I need to change that. And now it looks okay. Now you can go, or I can go to the real view and see if I have correct numbers. And it's a great way how to check if it's all right. And you can see that I forget to change numbers for the imported reinforcement, and I can easily change that. I don't have to like start from the beginning. Yes, also the same with the bottom one. If you feel like it's you are getting close in the reinforcement, there is a easy trick. You can turn off the rebar display, and then when you click on the selected reinforcement, only this one will be displayed, not the rest. So it's quite easy to get oriented again. Okay, and we can like check it if it's okay. Now I'm missing only stirrups, but before I will continue with the stirrups, there is one more trick I can use to see my selected reinforcement better. I can go to the preferences and I can pick some more wild color for current selection, for example the blue one, to see better. Okay, so now when I display everything, you can see that this color can be maybe better for some to find. Okay, let's go back to the 2D view and finish the reinforcement. Then it's almost like 80% work done, and I will input the stirrups. There is a small difference, as I mentioned in the beginning, that for the beams the model is same, but you have like some better options. For wall elements, you are not able to input stirrups, but you can use quite good workaround, and you can input the regular group of bars and just use the perfect bond, the anchorage type for that bars, and it will simulate the stirrups quite well. So let me show you. I will change the diameter, and then there is the perfect bond. So it will behave like a similar way, like a stirrups. I need to just change the position again. And also change the number. And also another great tool, people are always wondering how to cut the reinforcement, but it will be cut automatically. So you don't have to worry about it. Even when it's longer than the part of the structure, it will be cut. It can be seen when you click somewhere else, it's already done. Again, automatically by the software. So I will copy that on the second part as well, and I don't have to change anything. And finally, the last reinforcement is for the column. Again, stirrups, I will just change the parameters. I will keep the perfect point because I want to have stirrups there. And I will define it by 2 points. So many or some customers say that the reinforcement or input to input reinforcement can be quite tedious, but it's still much easier than to model every bar and then to do the connection between the finite elements because the software does it for you. Okay, I'm almost done. I just need to change the position so it's not inclined. And then we can observe the whole model. Okay, see, it's done. We can see the model view, what actually goes to the calculation. So basically, that's why I don't care. I don't have the proper stirrups because it's 2D and the horizontal branch doesn't take into any calculation anyway. And for the rest, it's just some summary of the areas. So the model for the calculation looks like this, but I can use the real view to check if I have everything. Put it. There are my stirrups. Okay, so it looks good, and I can continue. It was probably the most difficult part. Now the load case. We have extra button for the load cases and the loading in general. So first, I will create the permanent load. Self-weight, it's calculated according to the volume. It's clear, but just don't forget to apply it for the all parts if you model the structure from the subparts as I did. Then I want to input a moment from the column and also other forces, but we are not able to input the moment directly. So I need to again use the workaround. It can be good to know if you often model just part of the structures as the frame corners and so on. So you usually have probably the global model from the 1D elements, and you are able to get from that model the internal forces like a normal force, shear force, and the moment. And you can easily recalculate these forces for the length and input it as the line load, and that's what I will do. So I will use line nodes for all the inputs. And sorry. No. And because it's not like the same, yeah, this one is for the moment that I was able to calculate easily from the stresses, and I just transfer it to the line font. And because it's not the same both sides, it will create me a moment. The same way, I can input also the shear load. This time it has to be in the different direction, and again it's only the force divided by the dimension, so it's recalculated for my solution like this. Okay, so my permanent load is done, and I will do the similar way the variable load. So I can copy that, And again, I will input the moment the same way. Now the moment is much more like dominant because it's variable load, and I just need to change it for the direction set. And also I need to input the rest. Sorry. I need to input the rest. Sorry, I got a little bit confused, so I need to find the right values. So I have moment. Now I will input also the shear force. And there is something I forgot, I think, in the first load case. No, it looks okay. Okay. Yeah, so for the permanent load, I have self weight of the structure calculated, and then the rest is taken from the global model. And for the variable load is taken completely from the global model. The last thing I need to do is to create combination. I will create only the basic ones, one for ultimate limit state and one and two for the serviceability limit states, characteristic, and quasi-permanent. For the quasi combination, I will use coefficient 0 for the variable load. And what's important, if you want to calculate or check deflection or cracks, you need to use the tick box. Otherwise, it's not calculated. So this way, we don't calculate the combination you don't need, and the calculation can be much, or the results can be that much faster. Okay, so we have everything. Now I can run the calculation. There, another trick, when you are starting with the iteration and you are not sure if it will pass or not, you can change the multiplier of the default mesh size for the bigger number, so the finite elements will be bigger and also the calculation will be bigger. But it's good to do only for the first iteration. Once you have your final finer design, it's recommended to change it back to the number 1, because with the multiplier of the mesh as number 1 were done all the validations and verifications. Okay, so this can be used only so for some like iteration purposes to make it faster. Also, if you struggle with the speed of calculation, check if you have your performance on your computer set as the best performance. Here in the system and power and battery, because it happens to me quite a lot that when I'm not plugged, it's changed to balance or best power efficiency, and it can affect the calculation a lot. Okay, so please change it when you want to make it faster. And we can try to calculate now what's happening. The software is meshing the model and do all the connection between the reinforcement and the concrete, and creating the finite element model and do the iteration. So now you can see that I have some summary results there, and that everything is green and my design passed all the checks. If I would like to see, like, do the proper check and the proper calculation, now I will have I would have to change it again, the multiplier for 1. Okay, we will probably, I can show you, you can display the mesh and you can see that it's quite big. It's quite big now. Okay, in the check tab, you can display the summary results and you can see the direction of the principal stress and the actual flow. Now, because the mesh is quite big, it doesn't look so good, but if it was number 1 or the multiplier was 1, it would be much better. And then you can observe the ratio for different parts. You can, wherever you click, then you can see the result for the part. Or you can display the stress in the concrete, strain whenever, if you are in the plastic part, or in the same way you can display the stress and strain or ratio for the reinforcement and so on. You can also see other check. Okay, I didn't set any limits for deflection, but you can also see the rest of the result: encourage stress limitation, with crack and deflection. But you can find this information about the results in every webinar and also in our knowledge-based article. I would like to more focus on when you are not passing, what's happening and how you can find what's wrong. Okay, so I will move back to the presentation. Okay, and let's summarize what I done and also what you can take from that, and also see some other examples. So at the beginning, I show you that you can choose from more entities for wall elements or beam elements. And basically what I said is that you can model everything from the wall elements, and that the model in the background, it's the same. For that, I created one example that could be that would be same from wall element and beam elements, and here you can see some results, and it's almost the same. The difference are only in the options you have during the modeling. For example, for the wall element, you can use the DXF import. You have different reinforcement inputs, especially for the stirrups. For the beam element, you can use haunches, you can use trim ends, so it's easier way how to input internal forces when you have only the part of the structure. But if you are not able to create the part of the structure from the beam element as you wish, you can try do it from the wall. The only difference would be in the crack width, because there is a little bit different model, and also there is different reinforcement ratio. So, and the calculation a little bit differs. So this calculation of cracks, especially for the elements that are like poorly reinforced and are loaded a lot by shear, there can be bigger difference. And this beam element is more accurate for that. It's based on the verification that was done by ETH. So when you have such elements or type of the structures, it's better to use the beam element and do proper stirrups, or at least keep in mind that you need to have some reserve for the cracks. But otherwise, you can use both. The next, what I did was I was using the coordinations. Be aware that you don't see at the first sight that you select something in the table, and it's better to also input these numbers, the number of the rows, to have the coordination inputted right. And for the line support, try to remember that there is option for compression only, and it's great tool or feature when you want to simulate piles or soil, and you can use user value that you calculate or that you take from the table. There were also some reinforcement tips how to simulate the stirrups when you have wall elements. As you can see, the B coefficient or the anchorage length reduction is the same for the perfect bond as for the stirrups, and try to use as much you can these like special features like DXFM for bulk modification or displaying of the rebars in different colors or turning off the like all the rebars and just keep only one you want to modify. Try to make it easier for you. Then what I did for the column, because it was only part of the structure, I inputted the recalculated moment and the forces. There is also even like easier way. You don't have to use the line load for the moment. You could basically just use two forces that are going in the opposite direction, especially if you want to use it for such a structure like this knee joints or frame corners, where you doesn't want to check these parts, but you want to see what's happening in the knee joints. So when you have such a structure and from some reason you are not able to use trim ends, for example, because we don't have a topology, the topology you need, we don't have the templates for everything, you can use the wall elements, but you need to set some support for trim end. We base the calculation on the equilibrium, and you basically input the internal forces at all ends, and then just the line loads to modify the shape. But when you try to model it from the walls, you need to set some support. It shouldn't matter where you input the support, when you input the rest of the forces correctly. You can see that this one from the wall elements has a support, and this is the resultant of the, or this is the reaction. Here I have trim end where I inputted all the internal forces, and you can see that the number is same. I have the example open here. So this is how it looks when you are using trim ends. You are basically inputting internal forces from your global model, and the load that is that appears or that is applied there, and the software calculates from these internal forces and the load these forces that are applied to the model. So it automatically does what I did in the example where it is modeled from or manually by me. Here I can see that here I inputted all the forces manually, but the result is almost the same when I check how the stress redistribution looks like, and also the value, it's almost the same. Just be aware when you are using this way of modeling for the wall elements, always try to create some like blank part. It's done automatically when you are using trim ends. When I did it, I just add extra length. Always add something extra than you want to check, because of course this is not for 100% accurate, but this part should be like just all right. And another important part, I will go back to the presentation. When you are, I said at the beginning that the concrete is not able transfer the tension, that everything is transferred by reinforcement, and it's true even for the forces. So when I have force that's causing tension in the concrete, it would make my calculation unstable or it would fail. So I need to use transfer divide or load transfer divide that will transfer the load straight to the concrete, straight to the reinforcement. Okay, so I used a patch load. Otherwise, this part would like fall out. I will show you on other example how it looks like when it's not inputted correctly. So it's possible to model part of the structure, but you need to set boundary condition, input the internal forces in correct way, and also apply the internal forces to the structure in correct way to make it work. Here you can see how the patch load works. Basically, when to use this feature, it will connect the load to the reinforcement first. And you can find it in model entities, right under supports. There are also load transfer devices that you can use. Okay. So for some cases, it can be better or more accurate to use the line load, especially if you want to check the area of the area under the loads. Okay, because before, when I had the knee joints, I already wanted to check the joint itself, but here I want to also see what's happening here, so it's better to do it more accurate way. Okay. Now about the calculation control, check always the best performance and use the bigger multiplier for the initial calculation, and when it's passing, then check it back to the number ones to have accurate results. And now the last topic, something about why your calculation might fall or what's happening. We have some stop, let's say we call it stop criteria in the calculation, or different reason why it's not going to the end, but they are not, you will not find them in the, you will not find what exactly is not like why it's falling. Okay, so you need to know what are the stop criteria, because you will not find it in the application. So we have basically three. We have maximum strain in concrete is 5% strain in compression and 7% in tension, but this number is only like for numerical reasons, because the software, they don't like zero when you have some like numerical solution. So there is at least small part, but when you have properly reinforced the structure, you wouldn't notice that it's there. Then the second stop criteria is maximum strain in reinforcing bars. It's 5% of the 5% limit strain. And the third one, it's the maximum slip in bond elements or the maximum displacement in anchorage elements. The other reason why calculation it's failing can be that the iteration do not converge. And now, some example what can happen. So, for example, when the 5% strain in compression in concrete is exceeded, it can be just like wrong design, like too much load for the structure. So you need to modify the design, of course. It can be also the sharp corner. So you can if it's just like 1 point, you can probably neglect it, but you need to be sure that it's not like stress concentration caused by the load, but it's just some like singularity. Then when it's the concrete in tension, it's probably, and when it's not like passing, it doesn't have to be the wrong design necessary. It can be just the load that is not applied correctly. So for example, if you have a big cover and there is some tension that can be covered by reinforcement, it can happen that the calculation fails and you need to think how to fix it. Or example, if you input the point load at the edge and or when you input the force that cause tension in the concrete and it's not connected with the reinforcement, it can cause that it fails. So it's necessary, not like wrong design, but wrong understanding of the application and how to and the inputting of the loads. I can show you now some example how it looks like and how to find what's happening. So here you can see that the calculation stopped because criteria were exceeded, but you don't see like which criteria. You know what you are looking for, and the best way what's worked for me is going to auxiliary. There are actually no checks. It's a advanced, like it's a tab for some advanced results, and here you can see the deformation from the ultimate from ULS combination, so it's nonlinear. And now I can see there's something funny is happening here, that like this corner is like falling or jumping away. So it's not like the whole design is wrong. I just applied the load by the wrong way, and I think it was this one, because I didn't connect this force with the patch load. So it didn't take into account the reinforcement. Okay, when I will calculate it again, I believe it will work. In the meantime, let's see what else we have. When the maximum strain in reinforcing bar is exceeded, it's usually again the like wrong design, overload, and you need to do regular modification, like increase reinforcement area, increase steel grade, and so on. When it comes to the third criterion, the maximum slip in the bond elements, it's not the one, but when it is, you probably forgot to modify the anchorage type. So just add the hook or the bond that represents the reality the best, and it should be okay. But what's the common question about the anchorage results is why I have always 99 point something%. The answer is that we are in the plastic branch for the most of the cases. like in this part. So this is there is the like 100%, because in the results you can see ratio between the stress and the limit yield bond stress. That's what you can see in the results. So this ratio is usually something between 99 till 100, but the stop limit is based on the slip or the displacement. And because we are here most of the time, you can see that the ratio differs only a little bit, because it's not so much inclined. Also, you can even get some results above 100, because the maximum criteria that is used for the stability of the calculation is 10 or alpha multiply the ultimate limits. So there is the stop criterion, and there is the 100% ratio of the stresses. Back to the previous example, you can see now everything is okay, and I am not even close to 100 in concrete. It was just a wrong way of applying these forces, this force. Good. And I think I have the last slide about the converging of the calculation. So it might happen that the software can find a solution when there is, like, for example, big deformation during one step. So it's similar when you have the tension in the concrete, or when there are some stability issues, when you have a wrong boundary conditions. And the non-conformity error would change a little bit. Now you can see there is a calculation stop because of divergence of nonlinear calculation, and it's quite difficult to discover, but usually there is some again some wrong applied loads and the concrete's getting to the tension, or check the boundary conditions. In this case, I didn't take the rotation, so it wasn't the boundary conditions wasn't right. And now if I would adjust this little change, I think it should pass. Okay. So it's good to know what can be wrong. It's not always that you did the design the wrong way. It can be just you need to modify on small things, and everything will pass. Okay, so that was it. You saw some tips and tricks about the reinforcement, how to make it faster using the DXF file, and also the same for the modeling, how to use coordinations, how to display the model in 2D, 3D, and what are the differences, and how to input internal forces when you want to model only part of the structure. And I will just in 1 minute show you what are we working on right now. In the future version, during I think in October, we should release detail 3D. You can now test it because it's available for everyone in a like beta version. And basically this application is dedicated for such examples that are quite tricky to simplify to 2D dimension, two-dimension cases. So for example, pile caps, footings, anchorings, and other more complicated foundations. In the future, we should be able to do it in 3D. Right now, we are focusing mostly on the anchoring. When you go 2D application and you start new project, you can even find a template of anchoring and you can try to explore it a little bit. It would help us to get some feedback so we can implement it sooner and you could use it also sooner. So you can even find the anchoring or footing template and play it a little bit. So like there are some changes in like theory, of course, it's 3D, not 2D, and also in the modeling, but in general, the application it's still the same, that most of the principles like are also the same, and also the results, it's just 3D. So that's what I'm working right now. Detailed 2D is already fully verified and validated and used in practice. We have some case studies on our website, and it's a very general solution that you can use for anything, any part of structure, and you can get ULS and SLS checks, but it's only for the simplified cases to the plane. Detailed 3D, it's not fully developed yet, it's still ongoing. Now the fully almost developed case will be the footing and anchoring, and the rest, the validations and verification will continue. And both you can use only for the reinforced concrete. Okay, so it was something about the news, and I think we have now time for the second question.
Yes, that's true, Petra. Thank you for the presentation. I hope it will help you in your future modeling and in your future checking of the structures. Now, let's stay for a while with detail 3D. I would like to ask you about what do you think? So let me switch the screens to my presentation. So, can you see my screen, Petra? Does it work? Yes, I hope it works. Okay, let's do the poll. I am wondering, what do you think? What use can you imagine of detail 3D in the future? So let me launch the poll. Would it be the best for anchoring, for example, at the edge of the concrete block, or would it be the best for the pile caps, walls loaded out of plane, or some general use for atypical structure shapes like, I don't know, box girder bridges and stuff like that? So we have about 50% of the votes. So I will wait for, let's say, 15 minutes, 15 seconds, and then present the results. As Petra said, we are going to release detail 3D out of beta at the end of the October, if I'm right, this autumn. So you can look forward to new features and, of course, verified solution. So I'm stopping the poll, and let's take a look at the results. It is quite a bit surprising for me because I was expecting that the most used, or the winner will be anchoring, but it's probably we have some concrete experts here, so you are probably going to use it for general use of atypical structures. Again, thank you for the results. Now there is a time for. Now there is a time for questions. We have basically two questions here. The first one is if the materials will be available somewhere. Yes, it will be. You will be able to find them on our web pages tomorrow. There will be recording of this webinar, and we are going to add the models we presented or Petra presented. And the second question was if there are any verifications of this solution. Yes, there are. Again, on our web pages, there is a support center where you can find verifications. There are about, I think, more than 10 verification articles that were done mostly by the ETH University from Zurich by Professor Walter Kaufmann. So feel free to go through them. Before we end, I would like to invite you to our campus, which is e-learning platform. It is completely free. You can find there courses for steel applications and also for concrete applications, for RCS, for detail, etc. Let me also invite you to the next webinars. In October, we will have a webinar, What's New in ideastatica 24.1. And in November, there will be another webinar called Connection Wednesdays, where you will hear some very useful information about our connection application. After the webinar, you will receive the email. It would be fine if you give us some feedback and fill the short survey. As I've said, recording will be available on our web pages. If you haven't tried ideastatica detail, you can go to our web pages and download the trial version. It's 14 days trial. And if you want to go through more learning and knowledge-based articles, you can go to our support center. There are more than 1,000 articles about our applications. And that's it. Thank you for listening. Thank you for participating. I hope this webinar was useful for us, and I'm looking forward to the next webinars. Thank you. Bye-bye.
Thank you. Bye.